Hi guys, this is Mrs. Tucker. Today I'm gonna help you develop an understanding about scientific notation. And we're gonna start that by talking about powers of 10. I have given you each a little template to take notes on. So if you'll take out the first one that looks like this, we'll get started. Okay, it says let's start from the beginning, follow the patterns in the next couple of slides. Here's the first template that I want you guys to get out. Looks like this. It says powers of 10, positive and negative exponents. It's the one that just has different powers of 10 off to the side here. I've got it partially filled in for you. I'm going to help you fill in the rest. Okay, so let me grab a pen here. And let me make it a blue pen. All right, let's start off with something we know. Let's start off right here. 10 to the second power. You guys know that 10 to the second power means 10 times 10. That's what it means. That's called expanded form. And then when you multiply it out, then you've got what we call standard form. So 10 times 10 is 100. All right, let's jump down to 10 to the third. 10 to the third means 10 times 10 times 10. If you multiply that out, you get 1,000. Okay, well, we're following the pattern here. We went 10 to the first, 10 to the second, 10 to the third. What goes here? Yep, 10 to the fourth. 10 to the fourth means 10 times 10 times 10 times 10. That exponent tells you how many times your base of 10 is being multiplied by itself. It's being multiplied by itself 4 times. When you multiply this all out, you get 10,000. All right, here we've got 10 to the fifth, which means 10. We're going to multiply 10 by itself 5 times. 10 times 10 times 10 times 10 times 10. And when you multiply those all out, you get 100,000. Alrighty? Now, let's stop there and we're going to work backwards. I want you guys to notice that if you take 100,000 and divide it by 10, you get 10,000. If you take 10,000 and we're going to put this in here, divide it by 10, you get 1,000. If you take 1,000 and divide it by 10, you get to 100. Well, we're going to continue to follow that pattern. Let's take 100, divide it by 10, and you get what? Yeah, you get 10. So 10 to the first power, if you're following this pattern backwards, it's just 10. And I think that makes sense. You've only got 10 showing up once. So that makes sense. If you're following this pattern over here on your powers of 10 backwards, 10 to the 5, 10 to the 4, 10 to the 3, 10 to the 2, 10 to the 1, we get 10 to the 0 power. All right, if we follow this pattern backwards, if we take if we take 10, I'm following the pattern backwards, and dividing it by 10, 10 divided by 10 gives you 1. Did you know that 10 to the 0 power equals 1? Let's put that in there. Okay, we're following this pattern and we're missing the 0. All right, well 10 to the 0 power is 1. That's one thing that we need to know is any number to the 0 power is 1. I'll show you that in another slide. Let's follow this pattern backwards. I'm going to take 1 and divide it by 10. When you do that, you get 1/10. And in decimal form, 1/10 is 0.1. We've got 10 to the negative 1 power right here. I want to tell you guys that that's actually 1 over 10 to the positive 1 power, which is the same as 1 over 10. Write that in your chart. I'm in fact going to make this red so you guys can see that's a positive 1 power there. Okay, we're going to follow the pattern backwards now. We're once again going to divide by 10. When you divide by 10, if you take this number and divide by 10, you get 0.01, which is 1/100th. Right here I've got 1/100th. It's the same, isn't 100 the same as 10 to the second power? Well, if you're following this pattern backwards, this is 10 to the negative 2 power. And what I'm wanting to point out here is 10 to the negative 2 power is actually 1 over 10 to the positive 2 power, which gives you 1 over 100, or 0.01. Okay, I'm going to have to finish this up in part 2. See you guys in part 2. Powers of 10 in scientific notation. This is video number 2. Let's see here. Where'd we leave off? Okay. We are following the pattern here for our powers of 10. Did you guys notice here that when the 10 has a -2 power here, that gives you 0.01 if you're following this pattern backwards of always dividing by 10, which 0.01 is 1/100th, which is 1 over 100, which is the same as 1 over 10 to the positive 2 power. Okay, continuing to follow this pattern backwards, if you take 0.01 and divide by 10, you get 0.001, which is 1,000th. This is 1,000th right here, which, following this pattern backwards, is the same as 10 to the -3 power. And what I want you to write in also is 1 over 1,000 is the same as 1 over 10 to the positive 3 power. Following the pattern backwards of dividing by 10, we get 0.0001, which is 1/10,000th. That's also 10 to the -4 power. Working this pattern backwards, that's 1 over 10,000, which is the same as 1 over 10 to the positive 4 power. And we got one more level to go here. Dividing again by 10, we get 0.00001, which is 10 to the -5th power, which is 1 over 100,000, which is the same as 1 over 10 to the positive 5 power. I'm picking all of these up from down here. All right, now having gone through all of that, there's 3 things I want you to notice. The first thing I want you to notice is 10 to the first power gives you 10. Any number to the first power is that number. Next thing I want you to notice is 10 to the 0 power gives you 1. And you'll come to find out that any number raised to the 0 power gives you 1. And the last thing here I want you to notice are all of these negative exponents here. All of these negative exponents do not give you negative numbers. These are not negative numbers. They're numbers less than 1. And they're getting smaller and smaller and smaller as that negative number gets farther and farther away from 0. They're not negative, they're small numbers they're less than 1 but greater than 0. Now the other thing I want you to notice is 10 to the -1st power is 1 over 10 to the positive 1st power. 10 to the -2nd power is 1 over 10 to the positive 2nd power. 1 over 10 to the -3 power is 1 over 10 to the positive 3 power. 1 over 10 to the -4th power is 1 over 10 to the positive 4th power. And 1 over 10 to the -5th power is 1 over 10 to the positive 5th power. Okay, let me pause this. Okay, so I wanted you guys to see what exactly is meant by a negative power. For algebra students, you are not in simplified form if you have a negative exponent. This is not simplified form here. 10 to the -5th power is not simplified. This right here is on your way to being simplified because you have a positive exponent, and then I would go ahead and put it in standard form. And in our algebra book, they leave everything in fraction form, not in the decimal form. Okay? I'm going to end this video here, and I'm going to start video 3 with another set of powers here that we can go through. So I'll see you in video 3. Powers of 10 in scientific notation, video number 3. Okay, guys, I want you to grab this little notes worksheet that I've given you, and let's take a look at this one. It's basically the same thing that we did in the last set of notes, except for I changed my base from 10 to a 2. But I'm still going to work the whole same process again and see if I can't reiterate those points that I'm trying to make. Okay? 10 to the 2nd power, you know in expanded form that, 2 to the 2nd power in expanded form is 2 times 2, which gives you 4. 2 to the 3rd power means 2 times 2 times 2. When you multiply that out, you get 8. So the next one that goes in right here is 2 to the 4th power. Written in expanded form, that means 2 times 2 times 2 times 2. When you multiply that out, 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 5th power means take 2 and multiply it by itself 5 times. So that's 2 times 2 times 2 times 2 times 2, which gives you 32. All right? So now we're going to work these patterns backwards. I'm going to start with 32. Let me move this so you can see it. I'm going to start with 32, and I'm going to divide that by 2, and I get 16. If I take 16 and divide it by 2, I get 8. If I take 8 and divide by 2, I get 4. So now let's fill this in. If I take 4 and divide by 2, I get what? Yep, that's 2. Following this pattern backwards, 2 to the 1st power just gives you 2. Any number to the 1st power is that number. Following this pattern backwards, I'm going to take 2 and divide by 2, and I get 1. Following this pattern backwards, 2 to the 0 goes right here, and it gives you 1. Just like in the last set of notes, 10 to the 0 power gave us 1. Well, following your pattern backwards, 2 to the 0 power also gives you 1. Okay, so here we go into our negative exponents. We have 2 to the 1st power, 2 to the 0 power, 2 to the negative 1. Let's go ahead and fill this out. This is going to be 2 to the negative 2, 2 to the negative 3rd power, 2 to the negative 4th power, 2 to the negative 5th power. Let's continue to follow our pattern backwards here. If I take 1 and divide by 2, I get 1 divided by 2, which is 1/2, or 0.5. Okay? And I want you to write this in also. That's the same as 1 over 2 to the positive 1st power. Down here, same as 2. Okay, I'm going to follow my pattern backwards. I'm going to take 0.5 and divide by 2. When you divide that by 2, you get 0.25. That's the definition of 2 to the negative 2nd power, which 0.25 is the same as 1/4. What I did was I took 1/2 and divided it by 2. 1/2 divided by 2 is the same as taking half of a half, which is a 4th. And a 4th is the same as 1 over 2 to the positive 2 power. Okay, that's 1 over 2 times 2, which gives you the 1/4. Okay, continuing this pattern backwards, I'm going to take 0.25 and divide by 2. Dividing a 4th by 2 is the same as taking half of a 4th, which is 1/8. And 1/8 is the same as 1 over 2 to the positive 3 power. That's 1 over 2 times 2 times 2. All right? Following this pattern backwards, I'm going to take 0.125, divide by 2, and I get 0.0625. Well, what I did was I took this number here and divided it in half. I took half of 1/8, and half of 1/8 is 1/16, which is the same as 1 over 2 to the positive 4 power. Okay, we got one more level to do. We're going to take 0.0625, divide it by 2. When I do that, I get 0.03125. This is video number 4 on scientific notation and powers of 10. I was hoping to get that last one in before that video ran out. Okay, so we took this one, we divided by 2, and we got 0.03125. That's the same as taking 1/16 and dividing it by 2. Dividing by 2 is the same as multiplying by a half, or taking a half of a number. A half of 1/16 is 1/32. That's 10 to the negative 5th power, which is the same as 1 over 2 to the 5th power, which is 1 over 2 times 2 times 2 times 2 times 2. Okay, so we've built our new chart here. There's 3 things, again, I want to point out here. The first one, 2 to the 1st power. Any number raised to the 1st power is that number, And I think that makes sense if you're looking at this pattern here. The one that doesn't really make sense, but you have to follow your patterns, is any number raised to the 0 power is 1. I showed you guys that in the when we had 10 for a base. Now I'm using 2 as a base, and we still get 1 as being the definition of any number raised to the 0 power. And the other thing I wanted to point out are these negative exponents. Anytime you have a negative exponent, you are not getting a negative number. You're getting numbers less than 1, and they keep growing smaller and smaller and smaller. They approach 0, but they never quite get there. The other thing I want you to notice is 2 to the negative 1 power is 1 over 2 to the positive 1 power. 2 to the negative 2 power is 1 over 2 to the positive 2 power. 2 to the negative 3 power is 1 over 2 to the positive 3 power. 2 to the negative 4th power is 1 over 2 to the positive 4th power. And 2 to the negative 5th power is 1 over 2 to the positive 5th power. Once again, for my algebra students, you are not in simplified form if you have any negative exponents. If you have negative exponents, what you've got to do is you've got to change it to this first to make your exponent positive, and then go ahead and put it in standard form. All right? Okay, I've got one more slide I need to show you guys. One more set of notes we're going to fill out. It's on, specifically, we're going to talk about scientific notation here. Okay, so we're going to do the same thing with this slide here. Let's get started. Okay, let's start with 10 to the 2nd power. 10 to the 2nd power, actually, let's just go ahead and fill this whole thing out based on the set of notes we did earlier. 10 to the 5th power means that we've got 5 zeros after the 1. 10 to the 4th power is 4 zeros. 10 to the 3rd power is 3 zeros. 10 to the 2nd power is 2 zeros. 10 to the 1st power is 10. Any number to the 0 power is 1. Okay, this is from the set of notes that we did earlier. So 10 to the negative 1 power is 1 over 10 to the positive 1 power, which is 1/10, or 0.1. This can be 10 to the negative 2, 10 to the negative 3, 10 to the negative 4. So we've got 0.1, 0.01, 0.001, 0.0001, and here we've got 0.00001. All right, that's pretty much just copying what we did from an earlier set of notes from video number 1. Now, I'm going to choose a random number. I'm just pulling this out of the sky. I want to take this set of numbers right here and multiply them all by a random number, and I chose 4.5. Okay, so when you do that, here's what you get. If you take 10 and multiply by 4.5, actually, let's start with 1. If you take 1 and multiply by 4.5, you get 4.5. If you take 10 and multiply by 4.5, you get 45. If you take 4.5 and multiply by 100, you get 450. 1,000 multiplied by 4.5 is 4,500. 10,000 multiplied by 4.5 gives you 45,000. And 100,000 multiplied by 4.5 gives you 450,000. Right? Let's work this pattern backwards. If I take 4.5 and multiply by 0.1, I get 0.45. Scientific notation, powers of 10, video number 5. Okay, let's continue to follow our pattern. If I take 0.1 and multiply by 4.5, I get 0.45. If I take 4.5 and multiply by 0.01, I get 0.045. Continuing the pattern, take 4.5 and multiply by each one of these numbers here, I get 0.0045. Here I get 0.00045. And here I get 0.000045. All right? I'm going to write out longhand. When I took 4.5 and multiplied by 1, isn't 1 another name for 10 to the 0 power? So essentially what I did was I took this and multiplied by that. I took 4.5 and multiplied by 10 to the 0 power. Right here, when I took 4.5 and multiplied by 10, I was multiplying it by 10 to the first power. So I took 4.5 and multiplied by 10 to the first power. When I did this here, I was taking 4.5 and multiplying it by 100, and another name for 100 is 10 to the second power. 4.5 times 10 to the second power. To get 4,500, I took 4.5 and multiplied by 1,000. That's the same as taking 4.5 and multiplying by 10 to the third. Do you see what's happening here? Down here I took 4.5 and multiplied by 10 to the fourth, and here I took 4.5 and multiplied by 10 to the fifth. And the same thing happens working backwards. Here I took 4.5 and multiplied by 0.1. Another name for 0.1 is 10 to the negative first power. 4.5 times 10 to the negative first power. And let's just continue filling out this pattern. 4.5 times 10 to the negative 2 power. 4.5 times 10 to the negative 3 power. 4.5 times 10 to the negative fourth power. 4.5 times 10 to the negative fifth power. All right? I want to erase this here because there is now a point I need to make. Let me erase all this. This row right here is called scientific notation. All of these numbers are these numbers right here. This is called standard form. These numbers here are the same as these numbers in this column, but this column is called scientific notation. And scientific notation is a way to express really large numbers and really small numbers. I want you guys to notice that as my exponents here, my positive exponents get bigger and bigger and bigger, my numbers are getting bigger and bigger and bigger. They're getting really large. I want you to notice here, as my exponents get smaller and smaller, they're negative, they're getting farther away from 0 on the number line, they're getting smaller and smaller and smaller. My actual number in standard form is getting smaller and smaller and smaller and smaller. Numbers less than 1, they're getting closer and closer to 0, but they never get there. All right, this is the definition of scientific notation. We've got some rules of scientific notation, and I'm going to tell you all about those in the next video, in video number 6. Scientific notation, video 6. Okay, why use scientific notation? Scientific notation was developed in order to easily represent numbers that are either very large or very small. Here are 2 examples of large and small numbers. They are expressed in decimal form instead of scientific notation form to help illustrate the problem. The Andromeda galaxy, the closest one to our Milky Way galaxy, contains at least, oh my gosh, this is millions, that's 200 billion stars. That's a very large number. If you try to put that in your calculator's going to have a problem. On the other hand, the weight of an alpha particle, which is emitted in radioactive decay of plutonium-239, is, oh my gosh, look at all of them zeros. I don't even know what place we are out here. That's a small, small, small weight. If you try to put that in your calculator's going to have a problem. So we're going to have to convert these really large numbers, these really small numbers to scientific notation so that our calculators can handle it. Okay? Scientific notation is a way to express very large and very small numbers. It is written as a factor and a power of 10. I'm calling this part right here your factor, and this piece right here is your power of 10. Okay? The rule is, we all got to play by the rules. The rule is this factor, the number that's out front, must be greater than or equal to 1, and at the same time it has to be less than 10. That's the rule that we're all going to play by. So this number here, 2.75, is greater than or equal to 1, and at the same time it's less than 10. So that's the proper way to write a number in scientific notation. We're going to multiply by, if you multiply by a positive power of 10, that's going to give you a large number. Let me grab my pen here. 10 to the 4th power is the same as 10,000. If you take 2.75 and multiply by 10,000, you get a large number, 27,500. Multiplying by a negative power of 10 gives you a small number, or a number less than 1. It actually gives you a number between 0 and 1. 10 to the negative 3 power, if you guys remember, is 1 over 10 to the positive 3 power, which is 1 over 1,000. And if you multiply this by 1,000th is 0.001, if you multiply 2.75 by 0.001, you get this number right here, a really small number. So what I want you guys to notice here is if you multiply by a positive power of 10, you get a big number. And if you multiply by a negative power of 10, you get a very small number. Okay? A number is expressed in scientific notation when it's in this form, where the factor out front, what we're calling A, where A is greater than or equal to 1, and at the same time it's less than 10, and N is an integer. Integers are negative 3, negative 2, negative 1, 0, 1, 2, let me move this out of the way, 3, dot, dot, dot. Okay? This is a large number, so the exponent on the power of 10 is positive. We're going to convert this number to scientific notation. Because this is a large number, I know that the exponent on my power of 10 right here has to be positive. All right? What we're going to do is we're going to take this decimal point and we need to pick it up and put it in the number so that my factor out front here is between 1 and 10. So if I pick up this decimal point and move it over here, I get 2.483. 2.483 is between 1 and 10. And now to figure out what exponent goes here, you count how far. Scientific notation video number 7. Okay, we were trying to figure out what exponent goes right here. The shortcut is just count how far you moved your decimal point. 1, 2, 3, 4, 5 places. We moved it 5 places. So what we did was we took 2.483 and multiplied it by 1, 2, 3, 4, 5. We multiplied 2.483 by 100,000, and it gave us 248,300. This right here is this number in scientific notation. Okay, let's look at the next slide. The exponent of the power of 10 is the number of decimal places that you had to move the decimal point. Let's look at this number. This is a small number. So the exponent on the power of 10 is negative. Because this is small, we know we've got 10 to the negative some power. If we write this in scientific notation, the number that goes out front has to be between 1 and 10. So I'm going to pick up this decimal point and I'm going to move it into this number right here because 7.4 is between 1 and 10. Now the exponent, the actual number piece, is how far you move the decimal point. This is your shortcut. 1, 2, 3, 4. Okay? Multiplying this out, 7.4 is actually being multiplied by 1 over 10 to the fourth power, positive fourth power, which is the same as 10 to the fourth power is this, which gives you this, 10,000. So I'm going to replace that. Let me grab my pen. 10,000. Isn't 1/10,000th also written as this? Here's the tenths place, the hundredths place, the thousandths place, the 10,000ths place. So here's what we're multiplying together. And when you actually multiply those together, this turns into that number. This right here is called scientific notation. This here is called standard form. Let's take a look at the next slide. Don't forget, the factor must be greater than or equal to 1, but less than 10. That number out front has to be greater than or equal to 1, but less than 10. Okay, this is a large number, so the exponent on the 10 is positive. That's where I always start. We're going to convert this number to scientific notation. Where is the decimal point in this number? That's right, it's right here. I'm going to pick it up and I'm going to move it. If I put it right here, that gives me the number 52, but that's greater than 10, so I put it in the wrong place. If I put the decimal point here, that gives me 0.52, and that's less than 1. That's in the wrong place. I'm going to put the decimal point right here, because 5.2 is greater than 1 but less than 10. Now for the number that goes here, I just count the number places. Be careful, the biggest mistake is counting the number places because you guys go too fast. 1, 2, 3, 4, 5, 6, 7. And we converted that number to scientific notation. Here's a very small number. So I know the exponent on the 10 has to be negative. I'm going to pick up this decimal point. If I put it right here, I have 0.987. That's less than 1. It needs to be greater than 1. If I put it here, I've got 98.7. That's bigger than 10. I need to put the decimal point here. 9.87 is between 1 and 10. Now you count how far you move the decimal point. 1, 2, 3, 4, 5, 6. Be careful in counting. There's your number in scientific notation. Video number 8 on scientific notation. Look at them slime that decimal point. Okay, here's some examples. We want to take each of these two numbers and change them to scientific notation. Well, that's what we've been doing. This one here is a very large number. Since it's a large number, the exponent on the 10 is going to be positive. I'm going to pick up the decimal point, which is currently right here, and I'm going to move it into the number such that this number out front's between 1 and 10, 9.87. Now you got to count how many decimal places you moved it. This is your shortcut. Be careful on counting. This is where everyone makes their mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? On this one, I've got a very small number. So the exponent on the 10 is going to be negative since it's less than 1. I'm going to pick up this decimal point and I'm going to move it right here. So the factor out front follows the rule, has to be between 1 and 10. Now I count how far I moved it. Be careful. 1, 2, 3, 4, 5, 6. Now we've converted that to scientific notation. Now, down here we start off in scientific notation. We're going to express the number in standard notation. This over here is called standard notation. That's what we're going to do down here. So the first thing you need to do is look at the exponent. Is it positive or is it negative? It's positive, and since it's positive, we're going to wind up with a really big number. So what you do is you start off with your factor, and because it's positive, to make this a big number, you're going to move the decimal point to the right. How far to the right? 5 places. 1, 2, 3, 4, 5. What goes in the dips? That's right, zeros. Place your commas and rewrite the number. Hey, that wasn't too bad. I think that's pretty easy. Let's do the next one. We're given a number in scientific notation. They want us to convert it to standard notation. First thing you're going to look at is the exponent. The exponent's negative, so that means we have a small number. So you're going to take 9.72. You're going to slide it which direction to make it a small number? If you slide it this way, it becomes big. So we're actually going to slide it to the left 4 places. 1, 2, 3, 4. Put your decimal point there, and zeros go in the dips. Rewrite your number, 0.000972. We've converted from scientific notation back to standard notation. You can use scientific notation to simplify computations with very large and or very small numbers. Before we do that, I'm going to pause. I'm going to switch gears here. Hold on a minute. Okay, I wanted to pop up my graphing calculator on the screen here. I'm going to put in a really large, actually I'm going to multiply 2 really large numbers together, and I want to show you what happens. Let's take this really large number right here, and let's multiply it by this really large number right here. And you know that 5 times 7 is 35. Watch what happens. What does that mean? Well, what happens is the number is so large that you do not have enough display registers in your calculator to actually even display all the zeros. So what it did was it converted the number to scientific notation. So the 5.3 is your factor out front. E stands for exponent. So the exponent on your 10 is a positive 14. So that's what this means. Let me show you what happens when we put in a really small number. Let's put in 0.5, oh, no. Let's go back. I'll do it in the next video. Video number 9. Okay, we were going to put in a really small number. Let's put in this really small number and multiply it by this really small number. See how I just ran out of display registers? We're going to multiply those 2 really small numbers together. And when you do that, now you get this crazy thing. And what this means, the 3.5, the calculator has converted your number to scientific notation. So your factor out front is 3.5. Notice how that's between 1 and 10. This is saying the exponent on your 10 is negative 15. That's what your calculator's telling you. All right? Calculator has to have some way to display those super large and super small numbers and get its message across to you. So you have to be able to talk the calculator's language, and right here it's talking to you in scientific notation. All right. Let me switch back over to my other PowerPoint, wherever it was we left off. Right here. Okay, at this point here, I'm really talking more towards my algebra students. You can use scientific notation to simplify computations with very large numbers and very small numbers. The next 2 slides are for algebra students. This pops up in our book in lesson 7-2. We're going to use scientific notation to evaluate each expression. Okay, I'm going to take this and multiply it by that. Well, let's take each of these 2 numbers separately, convert them to scientific notation, and see what happens. This one here, that's a large number. I'm going to put the decimal point there. So I get 6.10 times 10 to the second power, because I moved it 2 places. And we're multiplying this by, okay, pick up the decimal, move it right there, 2.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I've got 6.1 multiplied by 10 to the second power, multiplied by 2.5, multiplied by 10 to the ninth power. And our associative property of multiplication says we can rearrange things and still come up with the same answer, so I'm going to rearrange. I'm going to say this is 6.1 being multiplied by 2.5, being multiplied by 10 to the second power, being multiplied by 10 to the ninth power. With me so far? All right, so 6.1 multiplied by 2.5 gives us 15.25 right here. And right here, 10 to the second power is this. And we're multiplying that by 10 to the ninth power. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 to the ninth power. When you put that all together, that becomes 10 to the what power? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th power. Hey, how did you get 11 from that exponent and that exponent? I'm just saying, giving you a little preview of the next lesson. Now, we're not in scientific notation yet because we said the factor out front has to be between what and what? Yeah, it has to be between 1 and 10. So, if I take this number right here and move the decimal point to right here, if I make it this, essentially what I did was I divided that number by 10. So if I divide that number by 10, to compensate for this division by 10 in that number, I'm going to multiply this over here by 10, and this gives me 10 to the 12th power. And here I finally got it in scientific notation. Okay? This piece here, if you divide the front end by 10, you got to multiply the back end by 10, and that's 10 to the first power. If I added another 10 out here, I get 10 to the 12th power. I'll see you in the next video. Now, what are we up to? Video number 10? Okay, let's keep going. On number 2, we're going to multiply those two numbers together. Let's do this. Let's convert this to scientific notation. That's a really small number. That's going to be, if I pick up my decimal point, I'm going to move it right there. That becomes 9 times 10 to the, it's a small number, so the exponent's negative. 1, 2, 3, 4, 5, 6. 10 to the negative 6 power. This number right here is a large number. That's a large number. The exponent on the 10 is going to be a positive number. We'll put the decimal point there. 3.7 times 10 to the 1, 2, 3. So we are multiplying these two numbers together. I'm going to use my associative property of multiplication to rearrange things, because it's 9 multiplied by 10 to the negative 6 power, multiplied by 3.7, multiplied by 10 to the third power. That's going to give me, if I rearrange things, I'm going to take 9 and multiply by 3.7, multiplied by 10 to the negative 6, multiplied by 10 to the positive 3 power. All right? So if I take 9 and multiply by 3.7, this piece right here becomes 33.3. 33.3. I'm going to go back to my definition of a negative exponent right here. 10 to the negative 6th power is 1 over 10 to the positive 6th power. And I'm multiplying that by 10 to the 3rd power. I'm going to make it a fraction by doing that. Okay? I'm going to write these two out in expanded form. Let me see if I can make a copy of that and do that in on another blank sheet of paper. We've got 1 over 10 to the 6th power being multiplied by 10 to the 3rd power over 1. Okay, here we go. This piece right here, let me switch back to blue, means 1 over 10 times 10 times 10 times 10 times 10 times 10. That's being multiplied. Let's put this in expanded form. 10 times 10 times 10. Multiplied it together 3 times. Now, if we do tops times tops and bottoms times bottoms, we get this. 2, 3, 4, 5, 6. Whoops, that's supposed to be a 10, not a 6. I get a little carried away there. And now I hope you guys see that this 10 up here cancels out with this 10 down here. This one cancels out with that one, and this one cancels out with that one. The only thing left in the numerator is 1. So you wind up with 1 over 10 to the 3rd power, which if we convert that back and make it look like scientific notation, isn't that the same as 10 to the negative 3 power? So all of this business here is the same as 10 to the negative 3 power. So let's go back to that original slide here. This becomes 33.3 times 10 to the negative 3rd power. I wonder how you got that from this. Take a look at this and take a look at that. I'm giving you a little preview. When you multiplied those together, you got 10 to the negative 3rd power. This is not in scientific notation until I move the decimal point right here. And what's going to move that decimal point over one place so that I change 33.3 to 3.33, I'm going to divide this piece by 10. To compensate for dividing this by 10, I'm going to multiply this over here by 10. This becomes 3.33 times 10 to the, let me go back to this slide. If I take this and multiply it by 10, that means I've got another 10 up here. This 10 cancels out with that, and I've got 1 over 10 to the 2nd power, which is 10 to the negative 2 power. This video number 11 got cut off there. Remember what we were doing here? We had to make this a number between 1 and 10. So if we divided this by 10 to make this 3.33, I had to compensate dividing this by 10 by multiplying by 10 here, which is 10 to the 1st power. And we did that back here on this slide. Whoops, not that one. We did it back here on this one, and we got 10 to the 2nd power. I just want to point out here, this is like foreshadowing for tomorrow's lesson. You start off with that, and you wound up with negative 2 as your answer. I wonder how we got that. Well, anyway, this is what you get for your final answer when you multiply these two numbers together. All right. Oh, let's do a little division here. Okay. What I'm going to do is I'm going to bust this apart. I'm going to put those factors together, and I'm going to put these powers of 10 together like this. Because if you did tops times tops and bottoms times bottoms, you get back to this. With me so far? I'm going to take 2.0286 and divide by 3.15, and I get 0.644. Now, let me write what I did here out in expanded form. There's 4 of them. 1, 2, 3, 4. I think that's 10 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. I'm dividing by 10 to the 3rd power. When you do that, These cancel out, and those, and I'm left in the numerator 10 to the 1, 2, 3, 4, 5 power. That's how I got this. I wonder how you can get that as an exponent from that and that. I'm just saying. Okay, we're not really in scientific notation yet because that factor out front has to be between 1 and 10. I need to move the decimal point right here. To make that decimal point move like that, I'm going to have to multiply this front end here by 10. That's going to give me the 6.44 that I need out front. Now to compensate for multiplying by 10 here, I've got to divide this by 10 here. If I pop up another 10 here, these will cancel out, and now I have 10 to the 4th power. Let me put a 1 exponent here. Wonder how you got 10 to the 4th power out of that and that. Anyway, this right here is your final answer for that division problem. The end. I'm finally at the end. You can watch this PowerPoint again. It can be found on Mrs. Tucker's webpage, or now you've got YouTube videos. So good luck with this, guys. See you in 7-3.